Okay, let's see. For this one, looks like we're finding the composite and then also finding the domain of the composite. So for this first round, we're going f of g of x. So that means that g is going in for this x right here. So this 3x minus 2 is going to go right in there. And that will look like this. So 3x minus 2 is the new x, and that's minus 1. And if I simplify that a little bit, we'll get 3x minus 3. So for domain, when we have one involving roots, the basic thing we got to look for is if I have some math under a root, if I'm trying to figure out what the domain of this thing is, it's going to be the math has to be greater than or equal to 0. And that's because I could take the square root of positive numbers and square root of 0 would be 0. But if I get to negative numbers, then that's the imaginary answers, and that's not part of the domain for the function. So for this, I just take this 3x minus 3, and whatever I'd come up with, I just take it and set it greater than or equal to 0 and solve. So now bring this 3 over. That's 3x greater than or equal to 3. Dividing out 3, I get x is greater than or equal to 1. And so for that, in interval notation, we would have 1 to infinity. If I do g of f of x, in that case, f of x is going, all of this will go right there for that x. So that would look like 3, and then square root x minus 1, and then minus 2. So again, all this other stuff doesn't actually matter. In terms of the domain, the part that does count is right there. It's the x minus 1. So then I would go x minus 1 greater than or equal to 0, kick the 1 over, and x is greater than or equal to 1 again. Didn't have to be, just that's how that worked out. And so this also would be from 1 to infinity. And then just to point out that this is consistent with some material we have already seen, if we think about what all these pieces are doing on this root, let's see, so that minus 1 would take my standard root and shift it right 1. The minus 2 would bring it down 2. And then that 3 would have stretched it, so instead of going over 1 and up 1, it would go over 1 and up 3. And so if you think of that graph, that is exactly what we have here, is 1 to infinity. And so that's why the 3 and the negative 2 didn't matter, because they didn't change the left-right, which is what the domain is. The 3 was the stretch, the 2 was a shift down. But what changed the domain from being 0 to infinity is exactly what's underneath the radical, which is our left-right shift, and that's why it messes with the domain. With this one, it's a little bit harder to see the 1 in terms of transformations. That seems way more work to my brain than necessary. So you can always just do this. I just want to show here that it ties into stuff we've seen. Cool. Hopefully that makes a little more sense.